Good morning to all dear students. In this today topic, we are going to discuss about the isotropic medium, homogeneous, how the electromagnetic waves are going to travel. Understood? Homogeneous and isotropic medium. Homogeneous, isotropic medium. Understood? EM waves propagation. EM waves propagate. Understood? How actually the homogeneous isotropic medium, the electromagnetic waves are going to travel. So here, first of all, we should know the last topic which we have discussed, particularly in the last topic we have discussed about the skin depth and attenuation. How the skin depth is going to happen and the attenuation is going to happen in any wire. Understood? So skin depth, what we have discussed, the skin depth also we are having the two types. Whereas homogeneous, I will try to explain homogeneous and isotropic medium and how electromagnetic waves is going to propagate. Here we will try to know. And here the skin depth we have discussed, skin depth and attenuation. Then it is linked to the homogeneous and isotropic. Homogeneous is what? Homogeneous is nothing but same. Wherever we are trying to, the waves are going to travel from one medium to another medium, it will remain same. It does not going to change. Understood? That is called what? It is called the homogeneous. And what is attenuation? Is a different topic which is related to the isotropic. Isotropic means if we are compared to one layer to another layer, the number of the particles are concentrated in the dielectric medium is remain same. Here and here will remain same. That is called what mark is called the isotropic. I will explain in detail what actually the homogeneous and what is isotropic we will try to discuss. And here we have discussed about the last class about the skin depth. The skin depth is particularly the propagation of wave from the rarer medium to the denser medium. Understood? Whenever if you try to take the rarer medium and denser medium, the wave is going to travel from one medium to the another medium. So here what is going to happen? Definitely it is going to propagate. Understood? The wave is going to propagate from one form to the another form. And it is going to penetrate from one to another. So in which manner it is going to propagate? Definitely it is going to propagate through the some dielectric constant. Understood? If you take the material here, the dielectric constant, understood? Like this, if you consider the wave is going in what? It is going to touch it, and each and every layer it is going to touch about up and down. Understood? Down and up. So here what is about isotropic? Isotropic will explain, that is, understood, the propagation. You know very well now. The propagation is what? By substituting E is equal to E epsilon omega. E is equal to E naught now. E naught sine omega. Understood? E equal to E naught sine, you substitute, what will happen? We are going to get epsilon naught E naught. Here we are E naught sine omega. We are going to. So the propagation of the wave is going to take place in the form of what? In the form of isotropic. In the form of isotropic is going to take place. Understood? This is the one condition number one. And along with this, what is happening? It is going to form a homogeneous form. Homogeneous. So what is the difference between the homogeneous and isotropic? In isotropic, we are having this. In homogeneous, what happens if you are trying to see the 3 or 4 layers, different layers of the wire. Understood? So homogeneous and heterogeneous. Heterogeneous. If you compare both, what happens in homogeneous, wherever the wave is going, it will remain same. It will remain same. Roughly I am drawing the 1 and 2 is equal. So 1 is equal to 2. The wave propagation will remain same. Sine 9 and sine r. Also, so here what happens? The sine, the propagation is what happens? 3 is does not belong to the 4. Understood? 3 does not belong to the 4, but 1 is equal to the 2. That is happening why? It is happening due to effect of isotropy. Understood? Here, not possible. Not possible. Because no isotropy. No isotropy. Understood? So here what happens due to the effect of isotropy and no possible because there is no isotropic effect is there. That's why it is called the heterotropy. So what we call here the any wire if you're trying to take the propagation of wave from one form to the another form or a wave is moving from one direction to the another direction. What is going to happen? Definitely the wave is going to get the attenuation. Attenuation is possible, skin depth is possible, then only it is a homogeneous. Understood? In the wave, the propagation of wave inside it is not a homogeneous. It is heterogeneous. Means if you are taking a copper wire or a zinc wire, the attenuation is completely different. The skin depth is completely different for the one particle. The why it is different? Because the material is different. The dielectric medium is different. The dielectric is called the dielectric is nothing but the resistance to stop the medium, the permeability, the value, whatever we are having, the electric field value, both to multiply whatever we are having that epsilon naught and E. If you multiply both, then we can able to calculate the dielectric constant. And whereas if you try to see the some copper, suppose having here having the copper one, are the homogeneous, wherever you try, if I'm taking a different type of kinds of lead and aluminum if I'm taking, lead and aluminum if you are trying to take, what will happen? They will be different. It is completely different and it is completely different. We are not able to get the exact attribution. Due to that, what happened? We are not able to judge the homogeneous. So definitely if you try to compare the diagram 1 and diagram 2, diagram 3 and diagram 4, what we should know here the peak values, the amplitude peak values. Here the amplitude peak values will try to explain you the attenuation, how much amount of a quantity of attenuation is going to take place inside any material. If you are having the skin depth value like dielectric constant, here d is equal to what? D is equal to 1.5. D equal to 1.5, what will happen whenever we are having the lesser value of d equal to 1.5, then there will be less number of the attenuation will be there. Now you can easily travel. Understood? As dielectric constant is increases, the attenuation is decreases. Why? Because the wire, whatever the medium we are having, that is nothing but B is equal to sin 9 by sin 9. What happens? Mu is very, very greater than 1. If mu is very less than 1, what will happen? We are not able to get the exact changes in the values of the attenuation. Then we are going to get the difficulty here. So like this, if you try to understand exactly changes in the properties of matter, we can able to understand. So overall, so what topic we should understand? We should understand how the changes are going to take place from one form to the another form. Understood? So homogeneous will give, and we should also try to know the difference between the homogeneous and heterogeneous direct constant medium. If it is homogeneous, then it is isotropic. If it is a all satisfied, suppose we are having our skin depth is there, attenuation is there, isotropic is there, then only it is a homogeneous. If though we are having skin depth value and attenuation value there, if it is not isotropic, then it is not called a homogeneous. Then it is called a heterogeneous. We don't have stopping, but still what actually the variation? Then what happens? Whatever the layer, upper layer will have, it is going to affect and we are not able to get the bounce back. We are not able to get the bounce back of the values we are not able to get. Why we are not able to get the bounce back values? Because we are having some difficulty here. What difficulty we are having? Definitely, whenever it is getting the bounce back, the values are getting disturbed. The values are getting disturbed in such a way that we are not having the same exact changes. Exact changes values we are not getting, and the series of changes of the values of changes take place in such a manner that there will be no vibrational of the molecules will be there. There will be no vibrational molecules will be there. Then what happens? Definitely we are not able to get the changes of the substances, whatever we are having. So like this, if you try to understand step by step, then we can able to understand how actually. The purpose of this query is what the isotropic medium want to explain in detail how the particles are changing, how the behavior of the motion of the particles are changing. You please note down the key points. I will explain more detail about the changes, how it is going to take place. So here, how the changes of values are taking place, you try to draw. So when the waves are traveling from one medium to the another medium, the bounce back means the photons, whatever the photons or EM waves are coming back, are reduces, are reduces completely. Understood? So we can tell the difference homo and hetero. What happened? When homo, whatever is the amplitude, it will remain. The amplitude will remain same. Same lambda. Same lambda. Here what happened? Whenever you try to send the change, it does not able to come. Lambda, lambda. So delta equal to what happened? Delta equal to lambda minus lambda. And delta equal to same lambda plus lambda. Whatever you are having, the values will remain same. It does not able to going to change. This is the one of the important characteristics of homo and hetero. Understood? That is a difference we should try to, otherwise we cannot able to get the exact changes in the molecules. Understood? So we should know in this manner how the molecules are going to changes from one form to the another form. Homo and hetero changes are going to take place. So we can able to know here how the molecules are going to take place and returning back. Take place and take place and returning back. Like this, we should try to know each and everything. Otherwise, we cannot able to understand the changes in the molecule. So this is actually the fundamental changes of the molecules. We should try to understand. Otherwise, we will not get the exact value. So we should know step by step what are the changes are taking place in the molecule. Then we can guide according to the changes to the molecule. Understood? So like this, we should know how the bounce back of the molecules are going to take place by step by step. There will be no change in the molecules, but there will be a changes only by the step by step process are going to take place. That is called the homo and hetero changes are going to take place. Now, detailedly, what is the mathematical derivation? What are the changes in the mathematical derivations? We will try to know. But you please try to understand the lambda value, whatever we are having, does not remain same. It is going to change left and right. And here left change, right, left is completely going to change. It does not remain same. You may think it is different, but it is actually going to change from one point of view to the another wave point of view. Because the wave should satisfy what form u is equal to sin I by sin r. Another v is equal to sin I by sin r satisfied. Then we can know what other changes are going to take place in the model. So this is the exact terminology I am trying to explain you, that we can able to get the changes in the model. Understood? So let us discuss more detailedly about the other molecules and what are the changes in the electromagnetic waves are going to change. By step we should try to understand. So here the difference between homo, the water, the molecules here having same, here also molecules. Here will be a difference of the molecules will be there. Understood? So like that we should try to understand the concept. Now I will try to discuss in detail what is the expression, how to understand the changes the molecule state from the lower state to the higher state, how the electromagnetic are moving. And if you try to see all the radio waves are going to attract easily to what? To the sensitive device. The radio waves are one and longer wavelength, which can able to easily disturb the molecules which are present. Understood? So you please note down that, and again I will try to explain it in detail in the expression part. So now, dear students, now let us know about the isotropic homogeneous medium expression. What is the expression for isotropic and homogeneous medium? Understood? What is the expression for isotropic and homogeneous medium? Let us try to know point by point here. Understood? So let us conduct the non-conducting medium. Non-conducting medium. Non-conducting medium, any material if you are consider, and this non-conducting medium, the matter is moving, and when on mu naught, mu naught, d are same. Please note down in any material if you try to take down, like isotropic homogeneous medium, and the values of mu naught, epsilon naught, d are same in all directions. Whatever the molecules are moving, it will remain same. It does not going to change whatever it are there. Understood? Like this, you should try to understand. Now let us write the expression. We know from the Maxwell equation. Expression. From Maxwell equation, what we know, the Maxwell equation is trying to know that del dot d equal to understand? First equation. And del dot b cross equal to 0. Del cross h is equal to j plus d by dt. Understood? And del cross e is equal to cap under root minus rho d by. This is equation number 1, equation number 2, equation number 3, equation number 4. Now what is this first equation? It is about the dielectric constant. The first equation is expression of the dielectric constant. And second is the change of magnetic flux. And change of the curl of the total change of magnetic flux. Magnetic field, magnetic flux, magnetic electric field, rate of change of flux. This is explained about the Maxwell equation 4. This is nothing but parallel law. Change of magnetic field by changing the electric field. This can become 3 and become 4 also. That can become another. Now what we have done, now our target is here. We have taken the equation and we have multiplied. Now by applying and by changing these two equations, why we are changing? We are going to apply dielectric constant, whatever the dielectric constant isotropic electric medium are there, we are going to apply. Then we are going to get the new equations. Let us see what are the new equations we are going to get. Understand? We very well know that is del dot E is equal to 0, del dot H equal to 0, and del cross H equal to dG by dt. And we very well know d is equal to epsilon naught into E. Whenever d is equal to substitute epsilon naught into E in the equations. Then what happened? The modification of equation is going to happen. Understand? Let us write the modified equation here, or we can write dou epsilon naught E by dou. Understand? Like this, you can be able to understand it. And similarly, del cross E, B we have. Understood? So B equation can be written as mu into dou H by dou D. Now what happened? Taking the third equation. This is third, 1, 2, and 4. Third equation. Third equation, what is going to? We are applying the curve. Applying curve to the third equation. Then del cross H, del cross delta I naught d by dt. Del dot H minus del into del H cap. And this can be written as sum of rho by rho t del cross B. This is the ending equation. This equation is considered the fifth equation. This will explain about what the change of permittivity with respect to the electric field. What is going to happen? Now target is what? By equating 2 and 4. By equating another same equation by applying the permittivity. Then what we are going to happen? Let us see here. By getting del square H minus mu epsilon naught rho square H by rho t square. What is it? Del square H minus 1 by v square rho x square by rho t square. This is the ending. So equation 5 and 6. The 5th and 6th equation represent the actually the change of both the values. And here how we got mu and epsilon equal to 1 by v square. Understand? Because this is nothing but the actually generally v is equal to under root mu epsilon. So we are sending root to this 1 plus v square by 1 by under root mu. So mu epsilon is nothing but 1 by v square. So we are applying this. Hope you are following. This is the fifth equation. Fifth equation, what is written in fifth equation will explain how the change of magnetic flux is going to change from one direction to another. If you try to follow the point by point, we are telling about non-conducting. Non-conducting. If non-conducting is one of non-conducting field where no amount of electric field is going to enter. No amount of electric field is going to enter. It will remain same. It is not able to change with respect to time. It remains same. That is called the non-conducting. And epsilon naught and mu naught d are the same. All remain same. Does not need to change. Though whatever the changes are there, all the values mu naught, epsilon naught, d, what we are having the constant values, it will remain same. Though the time derivatives are going to change, it will remain same. So let us try to see here. You please note down. I will try to explain point by point what actually the expression is going to explain. So here the expression is explaining about one more point by point. It is going to explain about this first part. And first equation, del dot d is equal to rho is first equation. Del dot b is equal to 0. This is what that d is nothing but epsilon naught t into e. Understood? If we substitute d is equal to epsilon naught t into e, then only we are going to get the exact equation. Understood? Like this, we are having the one equation and the one derivation of the one part. Like that, we should understand what are the changes are there. Rho. Del dot d is equal to rho. This is the first equation. And del dot b is equal to 0. This is second. Like that, we are going to have the part by part. And here del cross h and del cross a. Del cross h equal to del cross a. J plus dv by dt minus dv by dt. So what is going to happen here? The equation is going to have del cross h, del cross a. And J, this J will explain the charge density. J is equal to 1 more rho into means charge density will explain how many number of electrons are going to travel inside, or how many number of the electromagnetic waves are moving inside the wire. Is nothing but the charge density. Rho epsilon naught into del cross H equal to J plus 20 by 20. And del cross J is over, it will explain about not only about change of displacement of current. Whenever the time changes, the displacement of current is going to change. This D simple represents about the change of displacement. The current is going to change continuously. Not only the constant is continuously trying to change. Del cross is equal to J plus 20 by 20. Understand? And del cross is equal to what now? Minus 20 by 20 equal to like the step by step, if you try to know here what is going to happen, we can understand del dot equal to 0, del dot is equal to 0, del cross equal to del cross equal to. Like this number of series of experiments, we can able to know how actually the waves are going to change from one point to the another wave. So del cross starting what happens, it is remains 0 for that, and finally it will also 0. When it is continuously changing, when it is moving with the charge density, what happens? Definitely displacement current is going to generate. It is nothing but electromagnetic. So what we are doing, we are integrating, we are adding the Maxwell equations with the isotropic homogeneous medium. So only we can able to understand what are the changes are taking place in the particle. Otherwise, we cannot able to understand what changes are the particle is going to take place. Understand? So we are integrating. Please note that del cross is equal to dt by dt is nothing but we are going to add all the equations, whatever the equations we are having, we are trying to integrate with it. Maxwell equations. Means isotropic homogeneous medium is integrated with the charge density. And not only charge density, we are changing the whole Faraday laws also for the isotropic homogeneous medium. And gradually by applying the del, what happens here? The equation is nearly equating to the one where that is equal to the 1 by v square. So 1 by v square what we know very well. I just now written. So fifth and sixth equation. Fifth equation we use the change of electric field. Similarly, we will get the del cross E is equal to minus 1 by v square rho h by rho t square equal to. So for the electric field, for the magnetic field, both these equations use the homogeneous isotropic medium where the velocity of light will remain 3 to 10 power 8 for the bond isotropic homogeneous medium. So fifth equation and sixth equation. Sixth and fifth. So only what happens is equal to 1 by under root epsilon naught mu naught. That is v. So v square equal to 1 by 2 naught. If you substitute, it is equal to 3 into 10 alpha. So what is going to understand here? We are going to understand how the electromagnetic waves are going to behave when they are moving with respect to the velocity of the. Understood? So like the point by point, if you understand that J is equal to rho into it and mu naught and epsilon naught D all are same with the isotropic homogeneous. So orally in this class what we have discussed the important equations 5 and 6. Now the magnetic field changes, electric field is also magnetic field is also changes with respect to the time. And electric field also changes. We are adding. So the basic fundamental is here we are integrating or we are adding the Maxwell equation because the whatever the equations which were discussed only the change of magnetic field explained. Whenever electric field is changing, magnetic field is changing. But here Maxwell change charge displacement dt by partial differential dt by dt. That is also taken into consideration. That's why we are having the problem. So we should know this point of how the charge densities are going to change by point. So this is about our today class. Now you please go through all these topics whatever we are discussing. So overall in this today class we will discuss very detailedly about the what does mean by the isotropic. Isotropic means wherever we are going it will remain same, homogeneous same. So when this follow the skin depth pattern is satisfied, generally we are going to get the what we are going to isotropic. If skin depth and another condition not satisfied, then this called what is heterogeneous. But heterogeneous will not discuss in the bonded media, in the unbonded media. Always we are discuss electromagnetic waves itself means we should take definite consideration to the what mark? Definite consideration to the bonded media. If there is no bonded media, then there will be no interaction. Because if you are having only one form, like these waves are coming, and there is no interaction, then what happens? There is no reflection. there is no transmission, then we are not able to get the information. Large amount of information, whatever is required, we are not able to get the exact information. So to get this exact information, definitely we should follow this rules and regulations. Then only we can able to get the fundamental changes of the model. Understood? This is the main purpose of the electromagnetic waves. Like that series of lectures were discussing on the how it is going to act the ionosphere and how it is act in the vacuum, how it is act in the isotropic medium, like that we have discussed. The basic purpose to use the telecommunication, aircraft, different type of technologies we have discussed in the last lecture. So overall, in this today lecture, we have discussed the expression for the isotropic homogeneous medium. Before the some background of skin depth, attenuation we have discussed, and what is isotropic, what is homogeneous, and what is the expression. How we are adding the Maxwell equation to the latest development of the equations. Before that only we are permitted to the Faraday's, but Maxwell entirely changed the total electromagnetic waves in the quantum. So this is about the today class. In this class, we will discuss the directly in the offline classes. Thank you for paying your attention.